Hey folks, today we're going to be solving the Excel challenge Whodunnit by Harry C. Watson, which was battle number 2 in the 2025 Microsoft Excel World Championship Road to Las Vegas. If you are hot on this Excel esports stuff, you may have come straight here from the live stream where you would have seen me and Klinsmann presenting while Washington or Nicola or Hayden or Jason wiped the floor with the other three or fought it out in a close battle or whatever. It was a really exciting match, or it will be a really exciting match. These tenses are really hard with this wibbly wobbly timey-wimey stuff, but the important thing is this was a great case with some really difficult parts in it. There were a couple of tricks which, if you were able to spot outside of the normal data stuff, would have helped you along a bit, but that last level was really, really difficult. If anyone cracked it within the time, they must be some sort of spy, and I'm afraid your secret's out. You just announce it to the world with a perfect score like that. And of course, we all know I'm talking to Div on that one. So let's jump in and have a look at it. It was a really tough case. I think Harry actually had a harder version originally that he wrote, and this is the pared back version. This is often the case with these very hard cases. There's some brilliant minds in these writing circles. But yeah, I think I may have done quite well. We'll see. The scores will be out. You all already know. I am sitting here waiting till tomorrow to even find out. I think because I got to do it under test conditions beforehand, because I'm obviously one of the presenters, I think I got through levels 1 to 6 pretty quickly. There's a video somewhere. I've not put it online yet, but I probably could do if it's of interest to people of me muddling my way through. I think I got through most of it in about half the time, and then spent the rest of the time failing to get level 7, then spending another 20 minutes to get to an answer to level 7, it not working for everything, and me not realizing that it was a locked reference that was causing it not to work. So, yeah, if that's of interest, we can always put it out, but for now, let's go and solve level 7. Quick little note from Editor Elliot here. I went through this the way that I was thinking about it before, and right at the end, I got a little bit waffly, and I realized that there was an easier way of doing this. So I'll stick that at the end. I'm still going to put the whole solve in the way that I was thinking about it originally, because that's how I got there, and it was only connecting those dots that got me to this faster method. Again, everything is easier when you know how to do it, but it ends up with a really neat looking solution that's a lot easier to look at and follow through, and you don't end up with that situation that we had before where there were two answers, where there were more than one possible solutions. I'll pop that at the end of this video. Make sure you check that out and let me know what you think. If any of you spotted that within the time, then good luck going into hiding, is all I can say. So here was the battle Whodunnit by Harry, looking very dapper there. We had lots of different codes. We've got two different ways of shifting things: an ordinary shift, where things are shifted based on Unicode, and then a long shift, which was based on the days of the week. For level 7, we were just intercepting correspondence. We have 30 messages. We have to work out who the sender was for each of these messages to work out who committed the crimes. This long shift first popped up in level 6, and it was based on what day of the week you are, and then it's applied from there. We also have this people tab, which tells us our ordinary shift numbers based on who the sender is and who the recipient is. And we have the correspondent tag, which is where we're going to be solving this from. So let's go ahead, let's start a timer and see how we get on. What are we going to do? Let's start by getting these people things sorted. So I'm going to, because we need to know the sender, I'm going to make an array delimited by one of they, because it rhymes. I can't type an ampersand today, that also rhymes. There we go. And we're also going to do that. And then I'm going to filter a whole lot by that second column not being blank. Okay, so that gives us our codes. We know from the questions that these codes are unique. I'm going to copy these codes, I'm going to cut these codes, and I'm going to pop them in this correspondence tab over here. So there's our code. Let's insert a thing here. Oh, Copilot. Message. Sender, receiver. Offset code. And this is going to be sender because that's the one we're interested in. Cool. So the other thing we need is this long shift data, which I'm just going to pop here for now. And we're going to use in our version of this the fact that we know that there's a word, the day of the week, and names of two people. No, that's level 6. The fact that we know that each message starts with the day of the week. So we're going to use that fact. So first of all, I'm going to do some setting things up. I'm going to set up this first. So the thing that really helped me crack this was the fact that, okay, so we can't say what the first letter is because that's not unique. We also can't say how long it is because that's not unique. But if we have the first letter and the length, and we remember to do our dynamic stuff, then this actually is a unique list. You can see that both the S's have different lengths and both the T's have different lengths. Likewise, anything that's 6 long is determined by the first letter, and anything that's 8 long is determined by the first letter. Wednesday, we actually know. Wednesday and Thursday, or Wednesday and Tuesday, we know what they are just purely based on the length. And then the others we can work out based on that first letter. That first letter won't be shifted by the along shift. The along shift works in such a way that the first letter in the message, the first character of the message, is shifted no times. And then if it were Thursday, then the second letter would be three times, 6 times, 9 times, etc., going up in 3s. So with this, that is the key to how we're going to solve this. So I'm going to transpose that a second. So we've got all of our messages. And for each of those, I'm going to grab the first word. Message, first word. Let's try and set this out nicely. Cool. And now we want the, so we can just call that day. Day letter 1 is going to be left of that. And then we also want day length. That's the other thing that helps us get our unique identifier. So anything that is a 7 is definitely a Tuesday. Anything that is a 9 is definitely a Wednesday. And for the other ones, we need to work out what day it is. So for this, we're going to be a little bit sneaky. We're going to do a unique of these to get the 5 letters that they can start with. We're going to ignore the fact that actually we know the 7 and the 9. We're going to use that to check at the end that we've actually done everything right. So what we need to do then is, first of all, we need the Unicode of those. This first letter will always be shifted 0 on this along shift because it's the position -1 times the along shift. So it's always 0, and then the second one is 1, 2, 3, 4, 5, or 6, and the third one is 2, 4, 6, 8, 10, or 12, or 0. So that's our Unicode for the first one. We can also get, I'm just going to pop that there a second, we can also get the Unicode of our first letter from there, and we know if we take those away from each other that that is our shift. So if it was an M, then it's going to be this. If it's a T, it's going to be this. If it's a W, it's going to be this. That's our ordinary shift amount. So these are our possible ordinary shifts. just going to pop them in orange for ordinary shift. The next thing to do is to check for each of these things. Let's use a map. All that works as a 2D thing is number X match this in our codes. Oh, it does work as a 2D map. That's cool. Don't need to do map. Cool. And I'm going to call these 1, 2, 3, 4, 5. So what we're doing is we're just checking whether or not these codes exist in our list of possible codes. Because if it's not in our list of possible codes, it can't possibly be the correct ordinary shift. So we can see on this first one that it must be the Friday because it's the only one that's true. So we can say, what do I want to say? I want to say if what do I want to say? I want to filter each of these rows by this. How does that work? So I want to, let's just do it manually. Let's go filter these by these. Is that what I wanted to do? Not quite. I want to filter the day of the week. There we go. And I'm going to drag this across to do the whole lot. And we can see that for some of them, we are getting multiple things. So let's see. So none of them have got more than 3. So that's good. So we've narrowed it down to a maximum 3 choices. But if we append that with our day length and now copy that across, we can check it one further. So here are our possible day lengths. If it's not a thing in those, then it can't possibly be true. So for example, for this one, it could be a Friday, a Tuesday, a Thursday, a Saturday, a Sunday. Well, there's nothing beginning with S that's 7 letters long, and there's nothing beginning with F that's 7 letters long. So it must therefore be a Tuesday, as that's the only one that begins with T and is 7 letters long. We can then, from that code, get our long shift. Hoping this is making sense. There's a lot of trickery going on here. So the next thing to do is to say for each of these is number X match all of these in our list of shortcodes. Now, again, we just simply want to filter that based on that. So we'll do it nice and easy. I'm sure there's a nice dynamic way of doing this, but my brain is not thinking of that at the minute. And now we have something that looks like it's gone a little bit wrong because we have 2 or 3 examples where we've got 2 options. We've got exactly 2 places where there's 2 options. One where it could be a Friday or a Sunday, and one where it could be a Monday or a Sunday. But everything else, there's only 1 example, which means that for everything else, we've only got 1 possible result. So let's look up what do I want to look up? So at the minute, what have we got? So F6. Cool. All right, so now what we want to do is we want to get the leftmost code of that. I'm going to do it like that. And then for these 2, I'm just going to grab it out. Excellent. And now for each of those, we want to look it up in this here and return our code. Oh, not that one. So we know what our codes are. Code 1, and then we're going to do the whole thing, and then we're going to do code 2 for those 2 extra ones. So our long code is going to be looking up this one here in our list of shortcodes here, returning that from our long shifts there. And that is everything we need, with the exception of those two edge cases, everything we need to work this out. Let's have a go then. The first thing to do is we need to split. I'm just going to do this with the first example, then we'll apply it to the whole lot. We need to split the entire thing. I used regex for this. So I did any character, which is what the dot is, and we're going to use match mode of 1. That's going to give us all of the characters. And then we're going to say Unicode of that, take away this, and then from that we're also going to take away, let's see, let's make this a let statement. Let's say, let this be the characters is that codes is the Unicodes. Off shift is going to be our codes minus G36, and then a long shift is going to be a sequence with as many columns as there are columns in codes, starting from 0, and our step is our long code. And then we're going to add our off shift. We're going to take away our long shift. Then finally, of course, we are going to, so new cars is going to be the uni car of that. If we call new cars, we can now see it says Friday value, I value, committed value. Now don't worry about those errors. Those errors are absolutely fine. Nothing to worry about, I am sure. We can actually see that one of these is a problem because oct to hex, the 2 is lost, but I've got a way of solving that as well. Now that is done, we are going to text join with nothing. We're going to say two row of this. I'm going to use 2 row to get rid of our errors. And I forgot our second argument of text join. Friday, I committed oct to hex. Obviously, we don't have the 2. So that's going to go all the way across like that. And where are our 2 special cases? Our 2 special cases are this one here, which we can see this is gibberish. And this one here, we can see it's not gibberish. So it's only Monday Gamma was my offense. We can see it's only this one that we need to actually worry about. So let's copy this whole thing. But instead of that code, hang on, let's cut that down. Instead of this code, we're going to grab this code. And instead of that code, we're going to use that code. And instead of this code, which was looking up the thing, we're going to look up the S. Oh, the S6 in there, returning from there. Okay. Sunday, I perpetrated is non-text. Hard to read without the spaces, of course, but that looks like a set of answers. So we can grab that answer. We can pull it all the way across and then replace the one that we need to replace with this one. There we go. The other thing we need is the code we used, which is going to be those ones. Again, we're going to need to grab that code from there. And then from these codes, we can get who it was that sent the message. There's our names. And now, finally, we're going to look up these in the correspondence here. Now, I know what you're thinking. We already saw on that very first one that octahex had the number removed. Now, it is the only one, I think, with a number in it. No, dectahex does as well. But let's use regex one more time to replace any numbers with a blank. It will keep everything the same apart from the 2 with the 2's in, which will remove them just like we had in our thing. So we can look up now these codes. No, we can say look up. What am I trying to do? I want to grab these codes. That's what I want to do. I want to grab these codes, one more step, paste them down here, and I'm going to say is number, search this text within this. I'm going to lock this to the column, this to the row. There we go. That is our matrix for finding things out. And now we can just do a two-way lookup. So we can say x lookup this in here, returning from here. And then we can look up true in that, returning from our names. That gave us Rachel, which is a great start, so that is our example answer. And there we go, a full score on level 7 with just 18 minutes, already knowing what I was doing. Whew, can't believe that was meant to be an earlier question and he has harder questions lined up for us. Harry, what are you doing? That was really tough. And only 160 points. I don't understand why this was only worth 8 points for a level. Honestly, I got to here, I think, in about 12 minutes. This, even knowing what I'm doing, took me 18. Let's have a really quick review because there's a lot of stuff going on there. We've got the messages. We've got the sender and the codes. We use the fact that every day of the week has a unique combination in English of the first letter and the length. We use the fact that the first word had to be a day of the week. And that first letter wasn't going to have to be a long shift. So that first letter tells you what the ordinary shift is based on the 5 possible first letters of days of the week. Those 5 possible codes we then checked against our list of codes, because if it wasn't in the list of codes, then there's no way it could have been used. We then used that to find the possible first letters and combined that with the length of those days of the week to find out whether or not it was even possible. So for example, it was not possible to have a day of the week that began with F and was 7 letters long. Filtering down on that, there are only 2 examples where there was more than one option, which means that even if we just barreled on through, we would have been able to work something out for everything apart from those 2. And in fact, just apart from this one, because it was the Monday for this example that we needed. What did we do next then? And once we got that sorted out, we could work out what our ordinary shift code was and what our long shift code was and use that to translate everything. For our 2 extra examples, one of them we could see that this actually then translated to Monday, so that was probably fine, and it was only this one we needed to do, so we grabbed the other codes instead, the other ordinary code and the other long shift code, and used that. We then joined it all together, getting rid of the errors, which were our spaces and any numbers. Now, we could have built in logic to deal with that ourselves, but we didn't need to in order to get to the answers. And finally, we created a nice little 2D array looking up the code to get the person that sent it and comparing that to the word we were looking for, which we could look up with our XX lookup to get the names as needed. Definitely not easy, definitely worth more than 8 points a pop. When you think about the fact that this whole thing's worth only 160 points, which is the same as this entire level here, which I think was a lot easier, and this level, which again I think was a lot easier. This was only medium. Why was that not stepped up? Really, really tough, and not a lot of points for it. I guess it was to put people off, seeing that it was worth a lot of points and jumping straight to it. I don't know. Really difficult because it was a sort of standalone level. Yeah, really, really difficult. I don't know about you. I am exhausted just going through that. I already knew what I was doing, and I'm still exhausted. That was so tough. Harry and the other Harry, the two of them seem to be battling it out to really make things as difficult as possible. It's really fun to solve, but boy was that tough, and I would love to get my hands on that uncut version. I think there was all sorts of other things going on linked to the name Whodunnit, which brings up ideas of clue. I think there may have been rooms and movement. It'd be really good to see what Harry had in store originally when he envisioned this. But I can see why they stepped it back. Like I said, even knowing what I was doing, that took me 20 minutes. I went on a bit of a ramble there. I'm probably going to cut most of that out. So the long and the short of it is that was really tough. It was really fun. Even knowing what I was doing, it took 18 minutes. I'm looking at it now going, there must be a simpler way. Maybe a simply comparing each one of the things against each of the 7 days of the week. Maybe that would have been faster. Just trying to work that through in my head now. Maybe that would have been faster. Maybe that would have been easier. Maybe it would have made more sense. Is that how you tried it? Did you have a go at this? I'm half expecting now that I've realised that Hayden or Nicola or Washington or Jason might spot that in the live stream, and this whole video is going to look like I don't know what's what, but we'll see. I'm hoping that this was useful to some of you. I might do a follow-up trying that solution that's just occurred to me. And yeah, hope you enjoyed the live stream. Hope you enjoyed this video covering it. And until next time, keep excelling. I'm going to try the way I just thought about as I was hanging up. I'm just going to give it a really quick go. Let's see if this would have been a better way of doing it. I think this probably would have been a really good way to do it if I had thought of it. Let's grab those over here. Let's do that and transpose them. So I want the first word. So if this works, I'm going to be so annoyed at myself. Regex extract this by random. There we go. Let's make ourselves a little let function. So codes. I'm going to call that Unicode of those. And that's codes. Awesome. The next thing we need is the day. In fact, we can wrap this whole thing in a if the length of code, and let's do our locking now, or remember, equals, that is not equal to the length of our day. My throat's going there. Then we're going to return an error. Otherwise, we're going to return our little let statement here. And then our day is going to be, oops, this one here. Lock it to the right. And it needs a comma. Cool. And then actually you want to do this whole thing again. So let's do the whole thing again. Awesome. And then we can work out the along shifts, which is going to be a sequence of length no rows, but the number of characters in this, and it's going to be, the long shift is going to be starting at 0 and stepping at this. I think that's right. Okay. So now I want, just for a minute, I'm going to do codes, take away, day, take away, along shifts. And that's going to give us random numbers there. It's going to give us random numbers Okay, some of my things aren't locked right. What did I not lock right? That should be locked on the row. That should be locked on the column. That should be locked on the column. So yeah, I should have named these things. That's what I should have done. That's going to give us an A. Right, so it is 6 letters long, but all the codes are different, which means that it's not that one. It's not that one. This one. Ooh, they're all the same except for one, and they're a random. Okay, why are they all the same except for one? Let's just grab out R. Just call that R for a second, and I want my day to come out. It's because this isn't in upper, so in capitals. So let's do that. And then, what's this called? Ordinary codes. Now they're all the same. So now what you want to do is you want to wrap this in a unique, with the second argument being true for wrapping across. And that for this one here is still going to give us random codes because it's not the right day. That's going to give us an A, that's going to give us an A, that's going to give us an A, that's going to give us a single code, that's going to give us an A, and that's going to give us lots of random codes. So now the only other thing we need to do is we need to say, change that to a result. Our result is going to be if the number of columns of ordinary code equals 1, then ordinary codes, otherwise an A. Excellent. There we go. Gonna copy those down, and now I'm going to row this, ignoring the errors. Ignoring the errors. There we go. Does that help us any faster? Yes, it does, because now there's exactly one code, and now we know where the ordinary code is. Ordinary code. Our long shift code is going to be the lookup of this in those, returning that. And then you just apply the logic that we did before. So we say regex extract of the message, all the characters, take the Unicode of that. I'm going to call that codes. We're going to do codes. We're going to do a long shifts, which is going to be a sequence. The length of this as the number of columns. Whoops, there we go. Starting with 0 and stepping along by this. And then we're going to do our codes, take away our long shifts, take away our ordinary code. And we're going to do the whole thing in a unichar. Unichars. And then, just like we did before, we're going to say text join. with... In fact, we don't even need to text them. We can just concat it. We can concat 2-row new chars, getting rid of the errors. And there we go. Okay, that was much faster. That is a much neater solution. Oh my goodness. Why did I not think of that before? That is neat. That is cool. Okay.